Currently, multiple artisans are required to pick up and rotate the blade 90 degrees manually before installing the blade clamp. Our ultimate goal is to make this whole process easier. Our objective is to design and manufacture a CH53E main rotor blade lifting device that can be installed on the blade while it is in the transportation cart, and then rotated 90 degrees for the installation on the helicopter. The reverse sequence will be required for removing the blade from the aircraft. For the project requirements, the prototype must operate with a safety factor of 5, perform with a load 2 times the safe working load or main rotor blade weight of 371 pounds. It also must be capable of rotating the blade 90 degrees and hold the blade in a stable manner.
This here is our lifting device. The device will be hung to the existing crane and lifted off the ground prior to operation. Upon assembly of the blades onto the helicopter, the lifting device will be hung above the transportation cart. An artisan will then hook the 2 nylon straps around the blade and the polyurethane rollers. The crane will then lift the device and the blade out of the cart and lower it towards the ground such that an artisan can operate the steering wheel. The artisan will turn the steering wheel, which then rotates the shaft. As the shaft rotates, the strap is pulled across the rollers, which then rotates the blade. Once the blade is rotated, it can then be brought up to the helicopter to be assembled onto the helicopter. This sequence also functions in reverse for the blade removal from the aircraft.
The gearbox operates with a 5-to-1 gear ratio and it is self-locking. With the wheel, it takes 12 full rotations to rotate the blade 90 degrees. To turn the wheel, 0.5 foot-pounds are needed. The maximum stress inside of the lifting device with a safety factor of 5 is 113.2 megapascals, which is well below the material yield strength of 710 megapascals. The stress concentrations are located at the end of the hook plate gussets shown in figure 5 with the red arrow. For the stability of the blade, the straps are placed 5 feet and 6 inches apart. In order for the blade to be lifted, the blade needs to experience 33 mph winds, while the leading edge of the blade is tilted 12.5 degrees above horizontal, as shown in figure 2. In order for the blade to slip out of the lifting device, it needs to be lifted just 19 degrees above horizontal, as shown in figure 4.
Currently, our budget totals $2,108.37 out of the allocated $3,000.
The plan for next semester is outlined here. Once we receive all materials, we will construct our prototype, then begin testing and preparing for our Senior Design 2 Expo.